In this presentation we are going to look at inverse Laplace transforms. Now this is going to be a simple enough one just to get us started. Find the inverse Laplace transform of the following function. So we're given this function in the question. Just as a remark, I use g of s to sort of say g for given in the question, and I use f for something that you would identify from the formula sheet. So g of s is equal to 2s minus 4 divided by s squared minus s minus 6. Now, s squared minus s minus 6, you can see quite clearly that that is a polynomial of degree 2, a quadratic. But in such situations, what you should try and do is to factorize that. Try to factorize it. There's some questions where you might find that a factorization is not quite so easy. In this case, you will find that it's straightforward enough. S plus 2 times s minus 3 is how you might factorize that. Okay? Now, let's move on from that. What we could do is, this is our expression over here, and this is the denominator factorized. What we're going to do actually, I'll just sort of skip ahead here and sort of see, is there a sort of structure in the formula sheet that could help us. So I'm just going to go to the next slide here. This is the formula sheet. This is entries from the formula sheet. This is entry 8 and entry 9. This is the time domain, and this is the corresponding Laplace transform. So what we are trying to do is actually sort of work in reverse. Okay. Now we have two expressions here. We have s divided by s minus a, s minus b, and we have 1 over s minus a, s minus b. So let's just go back here again. So we could sort of, what we could do here is sort of split this expression here into two parts, two additive parts. So we have 2s over s minus 3, s plus 2, minus 4s minus 3, or divided by s minus 3, s plus 2, and perfect. We can actually just have the constants, multiplication constants outside it. So we have minus 4 times that and 2 times that. Perfect. Now, we have s minus a, s minus b. Now just recall that it's our denominator is s minus 3, s plus 2. So s minus a, that corresponds to s minus 3. So here we have a equals 3. S plus 2 corresponds to s minus b. So there b is minus 2. Just watch out for that sign there. And a minus b, you just might notice that there is part of the expression as well. A minus b is equal to 5. So what we're going to do here, we have a, we have b. What we're going to do is set up, it's actually all we really need actually, the a's and the b's, and also these coefficients of multiplication, don't forget them. But as soon as we have the a's and b's values, we're actually pretty good to go. So on the next slide, we have 2 times a over a minus b. That's 3 over s, or 3 over 5. That should be, sorry, that should be a superscript there, that t. No, it's not a t on the side, so it's a superscript. Little typo. Let's get rid of that. There's always a little typo somewhere. So 3 over 5, that's a divided by b, a divided by a minus b, by e to the power of a t. Let's just sort of go back here a second and see exactly what I mean. I actually am talking about this bit here in particular. 3 is a minus b is 5, e to the power of a t, that's e to the 3t. So we have that bit there. Similarly, we have minus b over a minus b, e to the power of bt. So b is 2 in this case, so it's 2 over 5. e to the power of minus 2t. There we go. Now, just be mindful of the fact that it's, minus 2. So b is minus 2. So minus, the minuses cancel out. So we got a plus there. When b is minus 2 and we have a minus sign there, we get plus 2. Something similar over this side. 1 over a minus b is 1 over 5. E to the power of 3t plus minus e to the power of bt. So e to the power of 3t minus e to the power of minus 2t. There we go. Okay. Now what I'm going to do is multiply through. Remember our coefficients we're multiplying each term. We have 2s and minus 4. So 2 times all of this, we get 6 over 5 plus 4 over 5, and so on. Minus 4 times all of this, so we have minus 4 times 1. There we have that. Minus 4 times minus 1 over 5 e to the minus 2t. Just remember the plus sign there again. You have to be very careful with signs. Okay. Now, this expression here is pretty easy to fix. We have something fix up. We have an expression here that's in, there's another t superscript that's gone AWOL there. We have an expression that has e to the 3t over there, and we also have another one here. So essentially all we have to do is add them together. Likewise, e to the minus 2t, two expressions there, this one and this one, just add them together, and that's it really. So we have e to the 3t. I'm going to sort of just once and for all fix that. Let's just do that now. Bit annoying. Sorry about that. There we go. So e to the 3t, and we have 6 over 5. 6 over 5 times e to the 3t, and over here we have minus 4 over 5 e to the 3t. Just add them together, and we get 2 over 5 e to the 3t. Likewise, the other two, we have 4 over 5 times e to the minus 2t plus 4 over 5 times e to the minus 2t. Add them together, we get 8 over 5 e to the minus 2t. Just as a sort of important thing, actually, this function is only valid in t greater than or equal to 0. So it's always important in your exam question when you're writing that, just to put in a remark upon where the function is valid. And just so I have it done properly, I'm just going to get rid of this last t down at the bottom and replace it with the proper superscript, just for the sake of completion. There we go. So that's the answer down there, and that's it.